Okay, hello, this is Tristan. I will be teaching stoichiometry today. This problem right here is actually a limiting reactant problem, but there's a lot of stoichiometry involved with mole-to-mole conversions and stuff like that. So, I will read the problem to you. The fizz produced when an Alka-Seltzer tablet is dissolved in water is due to the reaction between sodium bicarbonate and citric acid. And then it has the balanced chemical equation for the whole reaction. In a certain experiment, 1 gram of sodium bicarbonate and 1 gram of citric acid are allowed to react. What is the limiting reactant? So first off, we are going to start by writing down what is given to us in the problem. So we have 1 gram of sodium bicarbonate. Hold on. And we are going to need to convert it to grams of CO2 to see what the limiting reactant is. Sorry, my hand's kind of in the camera, so you can't really see what I'm writing. "84 grams of sodium bicarbonate you figure out by doing looking at your periodic table and then adding up the weights of masses of all of the elements in the compound. Then you do the mole-to-mole ratio. You use that, you get it from the balanced equation up above that it gives you in the problem. And then you do the conversion of from moles of CO2 to grams of CO2. So you do the same thing where you look at the periodic table and add up the masses of the elements in the compound. And then you will get an answer of 0.524 grams of CO2. Now you need to do molar conversion of grams of citric acid and then convert that to grams of CO2. So you start out with the same amount that you did in the previous problem of 1 gram. And then you'll do mole on top, and then the grams on bottom to convert it to grams. Moles, I mean. Sorry, I'm kind of slow. And then for the next part, well, you have to write in the grams of how much they are together, the mass of all of it, which is 192 grams. Sorry, I kind of put another grams mark. Then you'll do the molar conversion, the mole-to-mole ratio of citric acid and CO2. And you'll again look at the balanced equation that it gives you, so that you'll get a 3-to-1 molar ratio. Sorry, I kind of ran into the answer from the other problem. Sorry, it's going to be a tight squeeze. And then finish off by converting the moles of CO2 to grams of CO2. So again, you'll add up the grams of carbon and then the grams of oxygen. So it'd be like 16.0 times 2 plus however much carbon is. And then if you multiply them all and then divide them, you should get 0.688 grams of CO2. The limiting reactant is going to be the one that is the smallest decimal, And so, of course, the 0.524 grams of CO2 is the smallest. So, sodium bicarbonate is the limiting reactant. And of course, you can see that we've done a little bit of stoichiometry in here. So yeah, I hope that helped to make sense more, all that stuff.